Anyway, let me check my screen.
Just notice, I'll stop sharing actually so that they can.
Yeah.
Kiran, are you ready? Kiran?
Yes,
Kiran?
sir.
Yes.
Yes, sir.
You use this try your screen.
Yeah, just a second. Some permission issues. Yeah. Seems I need to join back. Just a second. Yeah. Is my screen visible?
No, but not the presentation actually.
Yeah. Let me open it. Yeah. Is the presentation viewable now?
Yes, yes.
Okay, sounds good.
But make it a full screen actually. Presentation mode.
Sure. Yeah.
Kiran, can you introduce him?
Yes, sir. So, Vijay Ekambaram is a senior research engineer working in IBM Research India. He completed his BE in computer science from SSN College of Engineering in the year 2009 and MTech in computer science from IIT Madras in the year 2012. He works in the area of machine learning with a specific focus on applying AI to various industrial sectors like retail, fashion, supply chain, etc. He is also a master inventor from IBM and has invented 250 plus US patented technologies and published his work in various top conferences like KDD and Informs. He is also a recipient of several prestigious awards such as the IIT Gold Medal, IIT Best Thesis Award, Anna University Rank Holder, and is listed in Wikipedia's Worldwide Prolific Inventor list. Vijay is third on the list of scientists who hold the most patents in India, and he is the youngest amongst them. He is also in the top 10 in the world in terms of patent years.
Yeah. Thank you, Kiran. Thanks for the introduction. Happy to be back to SSN. Yeah. Thank you. Thanks, Balasir, for giving this opportunity. Yeah. Thank you.
It's all yours.
So, can we get started or?
Yeah, sure. You can start it.
Okay. So maybe for the next 45 minutes, I will kind of give a brief overview on this area of infusing artificial intelligence in the supply chain domain, right? So I think since we'll have a diverse audience, right? I mean, I plan not to go into too technical details on various machine learning algorithms, etc., right?
No,
But
all our CS
probably I
students
want to
actually.
keep this
All our CSE students actually.
CSE.
Yes.
CSE, fine. Yeah. But we'll be in different years, right? I mean,
Yes, second year,
or we just
second
have
year and
some
third year.
second year and third year, right?
Third year.
Yeah. Okay, that's good, right? Yeah. So basically, I want to give a brief overview on what are the possible research problems or interesting problems in this domain, right? And I'll kind of give a brief overview on various business problems and some introduction to how AI can solve them, right? I mean, but the main motivation of this session, we can think it in the way like, let's say, it could kind of seed few thoughts for your upcoming projects or any of the research papers that you guys want to do in your upcoming years, right? So I just want to give a brief flavor on this area. so that I mean it can act as a good seed for any of your future research work, right? And maybe feel free to maybe reach out to me for if you want guidance to work on any of these research threads in upcoming time, right? Uh, so that's the plan for the session. Should that be good, or is there any other expectations out of the session? I mean,
It's good actually. That's the idea actually.
sure, sounds sure, sounds good, right? Okay, I think I mean as we all know, right? I mean this AI is pretty hard. I mean we have several lot of latest advancements in machine learning algorithms and deep learning techniques, right? So maybe here we'll talk about the supply chain, right? So basically, let me minimize the screen, right? So basically, in supply chain, the problem is about the dead unsold inventory, right? So let's say we have some retailer, okay, and maybe since it's supply chain, I will take fashion as an example, and maybe give all the examples with respect to fashion, right? But whatever that I'm talking is not just related to fashion; it can be extended to anything. Fashion, I mean, is apparels, right? Let's say we have some clothing store, right? Like, and who wants to kind of make design different styles of clothes, and they want to sell it, right? So the whole idea here is how can we prevent some dead unsold inventory, right? So inventory, what I mean by here is so when a manufacturer is kind of creating, like, let's say hundreds of t-shirts, right? And only 50% gets sold out, then the remaining 50% doesn't sell, right? So that is what we call as a dead unsold inventory, right? And seems this dead unsold inventory is a huge problem in fashion domain. So the whole idea here is how can we predict this, right? And predict the sales of various products so that we can minimize this dead unsold inventory, right? So that's a high level problem, right? And feel free to stop me in between if there are any queries, right? I mean let's have the session more interactive, right? Because it's pretty lightweight topic, so feel free to stop me in between if there are any questions, right? So the whole idea here is we somehow need various machine learning models which can solve the mismatch between the supply and demand, right? So let's say the supply refers, let's say I'm manufacturing 100 products, but the demand is only 70 products are being used, then the mismatch is 30%, right? So how can we reduce that, right? The whole idea here is we want the right product to be in the right location and at the right time and at the right price, right? Somehow we need some machine learning models which can understand all this data and can say that, okay, now this product has to be in this location and it has to be available in this specific season with this price, right? So how do we do all this thing, right? I mean how do we plan these things ahead of time, right? So that's the high level business problem that we wanted to solve here, right? And specifically in fashion, if you see, right, I mean fashion are like fast selling, right? I mean fashion, it's extremely trend driven, right? I mean what is very famous last year may not be trending today, right? And the historical data is very minimal, right? And the kind of data that we get is not very large, right? So we can't have very deep learning models or anything in the fashion domain because we don't have very huge data available, right? So that's the idea, right? I mean, so the fashion is kind of very difficult to predict because it's a lot of trend driven and etc. And how do you want to make it better, right? And so I mean, just to give a brief overview, right? I mean I work as part of this AI for supply chain group, right? And we are a team of researchers, and the whole idea of our research team is to kind of build various machine learning techniques specific to the supply chain domain, right? And currently we're focusing on forecasting, right? I mean, so how can we enable a better forecast, right? And at the end of the day, we want to enable like a very intelligent, self-correcting supply chain mechanisms, right? And what are the different algorithms that we want to do, right? So that's our team's mission, right? So okay, I think this I discussed it. So let's see from a data point, right? I mean, what are the kind of data that is available in this space, right? So there are two sectors of data. One is the client data, and other is the market data, right? So let's take a very simple example. Like let's take Zara or any clothing like Max or somebody, right? I mean, they have a lot of products available online, and every product. We have data across multidimensional, right? I mean we have images of various apparels, and we also have, let's say, some textual description about these apparels, and we have some these are various transactional data, right? The transactional data says at time on a particular day how many customers bought we also have various trend data saying that various Instagram, or let's say there are various online sources where or forecast reports where they kind of say which dresses are very trending, etc. Right? So we have data in a very multimodal fashion, right? Starting from text to image and to time series, right? So with all this data, can we what all machine learning predictions that we can do so that we address our earlier question, right? I mean, how to kind of get the right product in the right location in the right time in the right price, right? So that's the high level uh, uh, problem that we want to do with the specific data set, right? And there are different dimensions here to solve, right? I mean, so basically this session I just want to keep it at very light level and kind of introduce various problems to the team, right? So that you guys can think over it, right? I mean, and see maybe each slide that I'm showing is a complete research area in itself, right? I mean, there are several publications already available, and there are a lot of more work to happen in these spaces, right? So but I just want to give a flavor, right? So maybe one theme is about this explainable sales analysis, right? So let's say we do some forecasting, right? So can we kind of say if a product is selling well, right? Can we say why this product is selling well, right? I mean, can we kind of identify whether this product is selling well because of the color or pattern or the fabric, or because of, let's say, some icons in the dress, right? I mean, so how do we identify that in a scale, right? Let's say we have a product of like 10,000 products, right? Can we have some machine learning techniques which can automatically identify this and say, so if you see this graph says that this product sells well, and the positive aspect is neckline and the discount that is being offered, but the negative aspect is, let's say, color or a few other aspects, right? So that gives a brief idea on how do we do it, right? So as another example, if you take this product, right? I mean, why this product sells better than the average, given that we threshold an average sales, can we say whether this product is going to sell better than the average or less than the average, right? So for in order to do that, I mean, there are various explainable models, right? I mean, game theoretic approaches where whenever you try to forecast a model, in addition to the forecasting, we have various sharp analysis or lime analysis that we can do on top of it, that tries to understand and says that, I mean, how better we can explain the forecast or explain the demand with respect to these attributes, right? So this is one theme, one area where, right, I mean, how better we can explain any kind of analysis that we do, right? Now moving on to the other theme which is called what if analysis, right? So this is another interesting space where the idea here is, let's say we have some dress, right? And which is having these parameters, like, let's say, length, pattern, effect, price, sleeve length, fit, right? So let's say, any questions? Okay, right. So let's say we have various attributes over here. Now if let's say some expert comes and says that, uh, what if I keep all the attributes same, but let's say instead of this specific neck style, I make it a round neck, right? Or I make it a v neck. So how that will kind of improve the sales, or how that will kind of reduce the sales, right? So the idea here is, given a machine learning model, fix certain attributes but slightly change few attributes and kind of figure out, okay, if I kind of change this attribute, then uh, how is that going to impact my sales, right? So this is another very interesting research theme, right? I mean, so here where there are a lot of techniques that we can apply, where we can understand, right? I mean, so how every attribute is impacting, and let's say we can do some various causal analysis to understand, given this attribute, if it is reducing, then how can we make it better, right? So that is one theme, right? And the other idea here is about surprise me, right? I mean, so the idea here is, now given several attributes, so in the previous theme, I mean, somebody has to manually go and tweak parameters and say, hey, what if I change the length of this t-shirt to something else, right? In the other way, the system will automatically figure out what is the smallest change that I need to do to the specific dress design, such that its sell through rate or sales can improve, right? So how do we kind of do some optimization on these parameters and try to identify that, right? And it automatically suggests, right? So if you see here, it says that given this dress, it says that instead of off shoulder, you make it a crew neck, right? And instead of this specific color, you change to this specific color, and this the system feels that it could increase the sell through rate from zero point 0.5 to zero point 0.7, right? So this is another interesting domain where we do various causal analysis and others to try to understand, right, how to change few of these parameters, and that could impact the sales, right? So that is one kind of a theme, right? Another theme is a traditional, let's say, a visual dashboard, right? So this is an area where this is about general trend forecasting, right? So let's say I have some historical data for the past 1 year. Now can you kind of predict the sales for the next 6 months, right? So if I'm able to effectively predict, then based on that I can effectively stock my products, right? So this is this, and how can we effectively do a better display of it, right? And then we can do this at a very store level or across stores, right? So here is a heat map. I think this is one of the project that we did earlier, where so we will provide a heat map, and we kind of show how the sales happen in different locations, right? Let's say some executive want to understand how different products are performing, right? He can just open the heat map and says that, okay, according to the heat map, I think maybe Delhi and Chennai, Mumbai, I think these are performing well, but let's say these locations, right? I mean, here the performance is not up to the mark, right? So what we can do to make it better, right? I think this is another area where we bring in the geolocations, right? So it's no longer just a machine learning based on product data, but we also bring in the geolocations, right? So now we have a GPS locations of various product that is being sold, and we need to correlate that with various product attributes, and then we want to do various machine learning predictions, right? Okay. And this is another thing of which we call as visual search. I think this is something commonly that we also see in Amazon and others currently, right? So let's say in online, I try to select a product. The system can show various similar products, which look very visually similar, right? And I can pick and choose what I want, right? So given a product, right, how can we kind of show more visually similar products, right? And this internally uses various vision technologies like CNN and other various embedding technologies to do this image similarity, right? And this is also another interesting space where I think this has been there for a long time, right? And but still, I mean, at an industry level, if you want to do it at a scale of, let's say, million of products, right? How do we do a better indexing, right? I mean, how do we kind of save space and time in order to reduce this indexing and kind of quickly fetch the top 100 similar products, right? I think these are some of the interesting problems here, right? And let's say once we have any machine learning model, right, I mean, can we kind of say what are the future importance to various predictions, right? And can you kind of say, so given this, right, I mean, how various attributes is going to affect, right, and kind of give an overview, right, so that the model that you're trying to predict is very explainable, right? And can you also show an impact, right? I mean, let's say if this specific product, what is the corresponding impact with respect to particular metric, right? So, and can we kind of give a graph for it, right? I think these are few areas around this explainable analysis, and I think that's a big research area in itself, right? So building explainable machine learning models, right? I think if you see take a lot of deep learning models, they are not very explainable, right? And that is I mean, that is one of the pitfalls of deep learning models, right? But now there are various advancements in deep learning where they also want to make the models very explainable using attention networks and others, right? So this is also another interesting space where you want to do machine learning models, right? Maybe understand what are the existing prior arts around, making it very explainable, right? And see maybe for a current business problem, what is the right model which will give a good accuracy as well as better explainability, right? So I think now let's just move on to some of the underlying algorithms. I think what I described so far is various business problems, right? And just to give a flavor on, okay, these are the problems that is kind of there in the supply chain domain, right? And there could be numerous solutions to it, right? And there are a lot of research problems involved in it, right? So, I mean, the research problem could start from very simple, from a univariate sales forecasting, right, to a very complex forecasting models with various external events, right? So let's say, I mean, all of this at the ground level, we want to somehow forecast and figure out the exact sales or demand of the product, right? and there are several models we can do to do it, right? And there are a lot of external factors like holiday kind of effectively impact the demand, likewise we have weather or events, right? So we want to kind of have models where which kind of takes in this external events as well as the actual sales data and try to do a combined modeling together, right? And here there are various problems where let's say if the external regressors are not available, or if only few external regressors are available, right, then how do you kind of do a modeling, right? And I think this forecasting itself is a big theme in itself, right? And forecasting on a large scale data set is another problem, right? How we'll kind of do a distributed data sharing, and how can you kind of learn that, right? So let's say you have data in, let's say, like few hundred GBs of data, like 300 GB of data, 400 GB of data, right? So given this scenario, right, so we can't even load the data in a single machine, right? So because let's say my Mac has around like 64 GB of RAM, right? I mean, which is a pretty high configuration Mac. But in this, even in this Mac, I can't load a data of, let's say, 500 GB, right? So we need to go move to like distributed data modeling, where you have data across several nodes, right? So the data gets shared across several nodes, and any training or algorithm that you do also should happen in a distributed fashion, right? I mean, so we should kind of get data from various nodes and do various aggregation and do it, right? So I think these are all other interesting problems, right? How to do scalable forecasting, right? So that's another piece to talk, right? And in addition, when we want to do forecasting, right, I think this weather data plays a very important role, as you kind of see here, right? So I think the red line indicates the weather trend, and the other line indicates the actual sales, right? So, and if you see that, I mean, they're highly correlated, right? So if you can even forecast the weather for a particular situation and then use that, then that also gives a very good impression, right? And can give a better prediction, right? Okay, another interesting research theme here is about do attribute based sales forecasting, right? So the idea here is um generally forecasting we use only time series, but we can also use a lot of product attributes, starting from the design of the color, design attributes, color pattern, right? And kind of use this and kind of learn a multitask learning problem, where every product is quantified in terms of these attributes, and we learn one model which generalizes at an attribute level, right? I think that's also another very interesting space where instead of learning one model for every time series or for every product, we learn one model for all products, right? So that we call as a multitask learning problem. So that's a very interesting space where we use all these attributes to do these generalizations, right? So it's and another theme is about forecasting for new products, right? So here the idea here is let's say in fashion every year we introduce a lot of new products, right? So if a product is newly introduced, we will not have any historical data. So if there is no historical data, then how can we do predictions, right? So that's another problem in itself, right? So without any historical data, can you do a prediction, right? So that's what this new forecast prediction talks about, right? So here we have various techniques where given no historical data, just using attributes and by transfer learning from other products, can we do a better forecasting for new products, right? And another domain is about the spatio-temporal demand forecasting, right? So I want to forecast, but grounded on various geolocations, right? So how do we kind of do that, right? I think these are the few areas, right? And if we kind of see, right, I mean, in general, the supply chain domain has things where saying that the product is available in all stores, or the product is just available in few stores, or the product is not at all available in stores. So it's like a new introductions, right? So we have combination of all this together, and we want models that could work across these sections, right? So how do we kind of build very scalable machine learning models is a big problem in itself, right? So okay, I think those are the common traditional things that we do, right? But in addition to that, I mean, there are also various other newer themes, right? So for example, um, if you take Instagram, right? Instagram, there are a lot of influencers, right? And every influencer, they kind of support various designs products, right? So can we track some signals from these external sources like Instagram? If you see this graph, right? I mean, so this is the blue line indicates Instagram post, right? I mean, the kind of number of posts on a different time scale or of a specific product, right? And if you correlate that with actual sales, it's very much matching, right? So can we use these external data sources and can do a better prediction, right? I think this is also a kind of a very interesting theme where how can we use this external data to, but one problem is getting this data is a bit difficult thing, right? I mean, because it will have a lot of other IP issues, etc., right? So that's another problem over here, right? And if you have these data, right, let's say if you take, let's say any product has a lot of reviews also associated with it, right? So can also learn, do some text analytics and kind of understand the sentiment of the product, how people like it with respect to various attributes, color, etc., right? And that can automatically say that okay, this product has this sentiment in the market, right? And the sentiment of a product kind of that indirectly maps to the sales of the product also, right? If a product has a very good sentiment among users, it might have a good sales, right? So how do we kind of understand these user reviews and kind of do a better forecasting, right? Likewise, we can also do text summarization, sentiment summarization, etc., right? Okay, now let's say if you do all this forecasting and these forecasting techniques are available, right? Now what can we do with this forecasting number, right? So there are various things that we can do. One is about the assortment planning, right? So in assortment planning, we think about, let's say, given like 10 stores and you have like thousands of products, how can you kind of figure out which product should go to which store, right? I mean, how can we plan the inventory, right? I mean, so that is something, what set of products I should stock in each store, right? So this is a big optimization problem in itself, right? And how can we, and in order to do that, we need to forecast, right? And how our forecasting models is going to help here, right? And the second is about the assortment refinement, right? So can we kind of, if a product is not selling well in a particular store, can we move that to a different location, right? Third is about the stock allocation. This is very similar to the assortment problem that I said already, right? So, and also we can do a lot about the markdown optimization, right? So markdown refers discount, right? So can a system automatically figure out for this product you should have a markdown of 10%, right? Can you automatically figure it out, right? So another domain, very interesting domain, I think this is something which is very recent, is about algorithmic product design, right? Can a machine learning algorithm automatically design a fashion design, a fashion print, right? I mean, can it automatically come up by understanding various things, right? Can we say, okay, so here is a new design that I created, like, I mean, this we call it the creative, right? So there are various GAN techniques and others, right? So can it automatically come up with a design in its own, right? So I think these are the various problems, right? And another very interesting research angle to this is sustainability, right? I think right now, building sustainable models is very very important, right? I mean, if you see fashion, if there are a lot of dead unsold inventory, then they have to be dumped somewhere, and that is going to lead to a lot of wastage introduced into a world, and that's going to reduce the sustainability, right? So having a better prediction can lead to improved sales and reduction in the inventory, that can lead to a better sustainable industry, right? So on this space, right, how can we build very sustainable models, right? I mean, so that's also a very interesting space of research that's available here, right? So I think to kind of I think I covered various aspects, right? To kind of summarize various themes here, right? I mean, so if you consider this space, the data is multimodal in nature. So we have data from text, we have data from image, we have data from time series, and we have data from various external sources, right? And we want to build multimodal, right? I mean, so we want to build models which can understand data across these various domains and build models. And also we want this data to be explainable, right? So let's say I say the sales of this product is going to be 100. Why is that 100, right? So we want to answer that question, right? And we also want to output uncertainties, right? So any prediction that the system makes, it comes with the error, right? I mean, it won't be accurate, right? I mean, so there'll always be some error associated with it, right? Can we quantify it, right? So here is a prediction, but I'm only 50% confident on it, right? So can we kind of give some quantiles that kinds of says what is it, right? And in order to do that, I mean, our team has a wide variety of knowledge, writing from deep learning models to supervised models and various sharp analysis and optimizations, right? And causal techniques with genetic algorithms introduced in it. I think this is a vast technical domain that covers a very huge stack of machine learning models, right? And that could lead to various business problems, right? And these are the various business problems that I kind of walk through, from sales analysis to demand forecasting, trend forecasting. I can do markdown optimization, promotion planning. Let's say I can do a post-mortem analysis of a sales report. I can automatically create products. I think this kind of slide shows a various business problem that can come from this invention, right? So I think these are the high level uh, thoughts that I had, right? So uh, maybe I think I will just pause and maybe take questions, right? But feel free to ask any questions in this space. The idea here is, maybe these are various research topics I discussed, around like 10 15 research themes over here, right? So each problem itself, if you kind of do some prayer art search, right, I mean, you will find a lot of literature in that, right? And there's a lot of research advancement that we can make in it, right? So, and this is a very interesting space where you can apply it on real data and see an actual benefit, right? So I just want to give a flavor of this to the team, so that, I mean, the team can maybe choose any of these. I mean, not just specific to fashion, right, but anything similar to it for any of your further research problems, right? So maybe I'll pause here, maybe, and kind of take any questions which the team has, right? Not specific to this invention, but in general, right? I mean, any themes around the research, or specific to machine learning, right? So I'm open to any kind of questions.
It's a nice presentation. I want to ask you something.
Yeah.
I'm audible, Vijay?
Yes, sir.
The semester is about to over actually. Can the students can take some internship, can work on this problem something?
Yeah, I think we can figure out some plan. I think maybe I can check with my lab. I mean, so what is the, because the current internship process is over, right?
Okay.
But there's a way for there are other opportunities to do internship. I mean, for if somebody is interested specifically in machine learning, right?
Okay.
But maybe I can figure out the process. I mean, so what is the available process, and maybe get back to you on
Or
that. Right? But
even it's a remote, it's not a problem actually. So they can work from Chennai itself.
yeah, right. So I think some process is available, right? But maybe there could be some things to be sorted with respect to IP and others, right?
Okay.
I think which maybe I can just check with my management, right, and see
Okay.
what are the possibilities, right? And based on that, maybe for the next summer, or maybe
The
when
winter
we
actually
start some
coming
projects, right?
December.
Yeah, when next winter, right? So we can kind of figure out some themes on that. Yeah, definitely. I think that should be possible. I will check it out. Yeah.
Okay. Sure.
Any other questions from the team? Maybe in general, I mean, since I'm also from SSN, right? I mean, so it's been like I completed my SSN in 2009, and it's like 12 years, right? So I'm kind of very happy to back to kind of talk to my fellow friends, right? So, and all my professors, right? So feel free to ask any kind of questions, right? I mean, in general, on any career aspects, right? So yeah, I'll be happy to assist. Yeah.
Feel free to ask questions.
Maybe can somebody kind of give a brief view on maybe what are all the any machine learning courses that's being offered in, like, the second year, third year, right? I mean, what kind of maybe I'm not very familiar with the current curriculum, right? So in third year of computer science, right? So what are the common machine learning courses that's being offered, right? Or we can take some electives, right? So maybe can someone, maybe, if we have audience on that set, kind of give me a brief view, right? So that I can also understand. Yeah.
Sushant, are you there? Sushant?
Yes, sir, I'm there, sir.
Can you tell the
Uh,
subjects?
Sir, we actually have an introduction to machine learning course in sixth semester.
Sixth. Okay. Okay.
Hmm.
Right. And any specific courses on like deep learning or something that's also available as an elective, let's say in your seventh semester or something. I mean,
Seventh semester is available, sir, as a professional elective.
okay.
Deep
Okay.
learning,
Okay.
yes.
Okay. 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 I think it's okay. So, mm,
Vijay, from 2018 onwards, we became autonomous actually.
oh,
And
okay.
all
Okay.
they
Okay.
belong to our autonomous batch.
Okay.
And then the coming current first year, they belong to 2022 batch actually. So for them,
Oh,
they study Python in first semester. Second semester itself, they learn data science actually. They have a course on data science.
ah, okay. That will be good. Okay. Okay. Okay.
I haven't gone
Right.
through the syllabus. They have a course on data science and C programming in second semester.
Okay. 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 Okay.
Semester is common. As usual, it's common for
Yeah.
all
Yeah.
branches. And
Yeah.
they study Python now.
Okay. Okay. Yeah. I think most of this is underlying is Python language, so it's good to have a good understanding of Python, right? But in general, I mean, there's a good there's a lot of opportunities uh, from placements and others in the specific to data science, right? So any good programming skills around this machine learning models, like let's say TensorFlow, PyTorch, right, and a good hands-on with Python, right? I mean, the kind of opportunities available outside is very enormous, right? So maybe that's also one angle where maybe people can, well, they do their final year projects, right? Maybe choose some electives which could give them a flavor of this various machine learning and techniques, right? So that it can have you can kind of focus a very specific theme going forward. I think given that no lot of data is available, right? I mean, every enterprise models are trying to have various machine learning team on top working on top of it. Yeah.
For this batch, they can do some ACP approved NPTEL courses actually.
Yeah, very much, right?
And they can
So
weight their professionality on open elective, which they are supposed to study in the 8th semester.
yes.
And they can do a complete 6 months internship or some project. They can do a complete 6 months actually.
Yeah. I think there are a lot of coursework. I mean, you can see Coursera or
Ah.
NPTEL, right? NPTEL also we have a lot of.
No, but
I mean,
ACT mandates only NPTEL courses actually. They are not
okay.
they are not agreeing at the Coursera, Udemy or something. It's
Yeah,
not
NPTEL
allowed
is
actually.
also very good, right?
Yes.
I mean, we have a lot of our friends. I think a lot of specific topics on NLP, vision, even very specific themes. We have a lot of courses available in NPTEL, right? So it's I think irrespective of the coursework, I mean, we can also, if students are interested, they can take it offline
Ah.
and understand this, right? And try to have some projects. I think they will also have some assignments or anything, right?
Yes.
So we can take those things, right? I think that will kind of give a good flavor. Yeah.
They do a 12-week course. It can be weight for a 3 credits actually.
Oh, that's good. Okay. Oh, okay. The proper. Okay. That's very good, right? I mean, so.
And that will be mentioned in the transcript also.
Oh, really? Okay.
Because
Okay.
otherwise,
Okay.
the transcript, the number of credits will be less.
Credit will reduce. Okay.
Yes.
Yeah.
So
That is
it
true.
is mentioned there actually.
That is good. Okay. That is good. Yeah.
And from
That is
current
good.
first year onwards, even their internship will be counted actually. It will also
Oh,
be
really?
mentioned in their transcript actually.
Okay. That's good. Right. Yeah, I think for a internship of problem based, right? I mean, so maybe if we have more students who have taken these courses on machine learning or deep learning, right, and can maybe want to have pursue a kind of a core research problem in these domains, right? So then definitely, I mean, we can try to see what are the possible options available, right? And we can figure out the options to kind of have some remote internship or something. Yeah. Okay, I think I didn't have a brief slide. I just want to just give a brief overview. I don't want to overwhelm with a lot of technical details, right? So I just want to give a flavor of this domain to the students, right? So that if any of that feels interesting to the team, right? I mean, it could help them in the future front, right? So Yeah. So I don't want to do a very technical deep dive on to various like machine learning. Maybe if anybody's interested, maybe we can have another session on that later on. Yeah.
Any questions?
Cool. No problem.
Okay, then, Vijay, thanks for accepting our invitation actually.
Yeah. Thank you very much.
So anyway, we'll try to accommodate you in person actually, because now the COVID restrictions have been removed.
Yeah. Yeah. So
So
possibly
we'll
during
come
December time. Yeah. So when I come to Chennai, I think, right? So yeah, definitely I can come to the college and we can have some
we
in-person
can
session.
meet
Yeah.
this group actually. We can meet this group and we have a vibrant coding club and we also have a cyber security club.
Okay, that's good. Okay.
Finally, today they have their farewell actually, so they have won their edge. Otherwise,
Oh,
they
okay.
might have joined good numbers actually.
Oh, okay. 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 That's okay. Yeah. Okay. I think
So,
nice having a discussion with you all. Yeah. Thank you.
thanks. Thank you.
Thank you, sir,
Again,
for having this
yes.
opportunity. Yeah. Thank you very much. Yeah.
Thank you. Vijay.
Thank you. Bye.